Let us do a very important sum. This is going to be exciting. Let's see the sum. The sum says that there's a figure here. And in this figure, they are saying that bisectors of angle B and angle C in triangle ABC meet each other at point P. So these bisectors, they are meeting each other at point P. Line AP cuts the side BC at point Q, as you can see in the figure. It says prove that AP upon PQ is equal to AB plus AC upon BC. This is what we need to prove. Now when you look at the two proof, you'll say there are two ratios which you want equal, and in one ratio in the numerator you have addition. Okay, fine. Don't worry about that. That's going to be very easy. One thing we realize that we want ratios here. And if you look at the given information, it says that angle B and angle C, for these two angles we have been given bisectors. If you look at angle B, this is angle B. This angle B belongs to this triangle ABQ. Can you see that? It belongs to that triangle ABQ. And in that triangle ABQ, if you see very carefully, this BP is the bisector of that angle. And if it is a bisector, that means we can use property of angle bisector of a triangle. And if I use that, I get two ratios equal. What is that? If I start from A, then it would be AP upon PQ, isn't it? AP upon PQ is equal to AB upon BQ. And that's our result number one. Was that easy? Very easy, right? And we know the reason. This is nothing but property of angle bisector of a triangle. Was that easy? Very simple. So we got this. Now you would be saying, we use the bisector for angle B. Same way, can we use a bisector for angle C? Yes. In this triangle, in triangle AQC. Beautiful. So we write that. In triangle ACQ, right, CP is the bisector of angle ACQ. So we get two ratios equal. Start from A. So we get AP upon PQ is equal to AC upon CQ. Isn't that? And that is what we write there. And the reason for that would be the same property of angle bisector of a triangle. And that's our result number 2. Was that easy? Very simple, right? Now what has happened is this helped us to get the ratios. Now look at what we want. We wanted AP upon PQ. Have we got AP upon PQ? Yes, in result number 1. Have we got AP upon PQ? Yes, in result number 2. Beautiful. So when we look at these two results, that is result 1 and result 2, what do you understand? In both the results, we have AP upon PQ as a common ratio. That means we can say that this right hand side of result number 1 and this right hand side of result number 2 both are equal. Beautiful, right? That means we get right hand sides equal. Generally, that is what we would write. But in this sum, we will not write only that. I'll tell you why. What is the reason for that? Observe very carefully. So we'll write AB upon PQ is equal to AC upon CQ. But both the ratios, they are equal to what? AP upon PQ. You'll say most of the sum we don't write that. But here we'll write, because in the two proof we want AP upon PQ. That has to exist in the sum. So let's write it. So we'll write all the three ratios equal. AP upon PQ is equal to AB upon BQ is equal to AC upon CQ. These ratios we got it equal, and we got it from 1 and 2. Was that easy? Beautiful. We got this. Now, but what are we wanting? We want AP upon PQ to remain as it is, right? This ratio to remain as it is. But we want in the two proof on the right hand side AB plus AC. Now, we want AB plus AC. Observe, we want AB plus AC, AB plus AC. These ratios are equal ratios. And for equal ratios, I am talking about getting a ratio where we have the addition of the numerator. We can do that, right? But we know a theorem, that is theorem on equal ratios. So let's do that. So those two ratios there, we will keep AP upon PQ as it is. For the next two equal ratios, we add the numerator AB plus AC because we want it that way. And the denominator BQ plus CQ, and the reason here is nothing but by theorem on equal ratio. We know that this new ratio is equal to each and every ratio. We wrote it equal to the first one because we want only that, right? This is important. Now write the next one. So we get AP upon PQ is equal to, what is AB plus AC? As it is, what is BQ plus CQ? BQ plus CQ we know is nothing but BC. Reason is B dash Q dash C. Beautiful, we got that. Now look at the two proof. What have we want? We wanted AP upon PQ. We got it on the left hand side. On the right hand side, we want AB plus AC upon BC. We got that. And we got the proof. Wasn't that easy? Very easy, right? It's a beautiful sum. Very important one.